Hello and welcome to this International Society of Automation webinar. My name is Matthew and I will be your Global Spec moderator, and I want to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading Presentation in the upper left is the primary window for today's session. Just to the right of the main presentation window is the speaker bio window with background information on today's presenter. Just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed into the queue to address when we get to the Q&A session. At the bottom of your screen, you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with a description of the button's function. Now I would like to introduce today's presenter, Johan Nye. Johan is an independent consultant specializing in industrial control systems and cybersecurity. He has recently retired from a major petrochemical company with more than 38 years of experience. By the end of his career, he rose to a level of Distinguished Engineering Advisor and had the role of ICS Cybersecurity Advisor. During his career, Johan designed ICS system architectures, created company standards and policies, implemented major ICS projects, supported ICS site engineers, and contributed to the design of several ICS products. Johan has had leadership positions in standards committees such as the International Society of Automation ISA 84 Committee for Instrumented Systems to Achieve Functional Safety. He is currently part of the leadership of the ISA 99 Committee for the Security of Industrial Automation and Control Systems. He was a founding member and past chairman of the ISA Security Compliance Institute. Johan also participated in the development of the US NIST Cybersecurity Framework as a representative of the Automation Federation. Johan earned both Bachelor of Science and Master's of Science degrees in Mechanical Engineering from the Massachusetts Institute of Technology and has CISSP and GICSP certifications. Johan, welcome to today's event. And with that, we'll pass things along to you to get started.
Thank you, Matt. Hello, everyone. Today's agenda, topics we'll cover will be key messages related to industrial automation and control system cybersecurity and security life cycles. We'll cover the terms that are used in 62443, such as system, component, automation solution, and IACS. We'll cover the principal roles and responsibilities described in the 62443 standards. I'll go through a brief description of the standards and the technical reports that are available and planned for 62443. And we'll talk about two security life cycles that are described in 62443, the product security life, automation security life cycle. And finally, important note, some of the material in this presentation is based on ISA 99 committee drafts and is subject to change. So, key messages. The asset owner is accountable for the cybersecurity risk of the IACS and the equipment under control. While the asset owner is ultimately accountable, responsibility is shared between the asset owner, product supplier, and service providers. IACS cybersecurity is required throughout the product security lifecycle, and IACS cybersecurity is required throughout the automation solution security lifecycle. Here are some key terms that are used throughout the 62443 series. Components are used to build systems. The types of components identified in the standard are embedded devices, which are special purpose devices designed to directly monitor or control the equipment under control. Examples are programmable logic controllers, safety instrumented systems, or DCS controllers. Host devices are general purpose devices running a general purpose operating system that are capable of hosting one or more applications data stores, or functions. Examples are PC workstations or servers running Microsoft Windows or Linux operating systems. Network devices are devices that facilitate or restrict the flow of data between devices. Examples are switches, routers, and firewalls. And finally, software applications are software programs executing on the infrastructure that are used to interface with the control system or the equipment under control. Examples are historians, human-machine interfaces, or HMI, and advanced or optimizing control applications. So components are used to build systems, and systems are defined as the hardware and software components of an industrial automation and control system. Systems are composed of an integrated set of components. The automation solution is an installation at a particular asset owner's facility. It can also be considered to be a set of zones and conduits, and it can also be thought of as an integrated set of system and component products. The security program is the people and process parts of the security triad. Examples are the awareness and training programs, policies, and procedures needed to manage IACS security. And finally, the IACS is a collection of the personnel, hardware, software, policies, and procedures needed to safely, securely, and reliably operate the equipment under control. You can think of the IACS as the combination of the automation solution, or the technical part, and the security program, or the people and process part. It's helpful to understand the roles that have been defined throughout the 62443 series. The asset owner is accountable and responsible for one or more industrial automation and control systems. The asset owner also operates the industrial automation and control system and the equipment under control. The product supplier manufactures and supports IACS hardware and/or software product. There are two types of service providers defined in the 62443 series. The integration service provider, also known as a system integrator, provides system integration services for an automation solution, such as design, installation, configuration, testing, and commissioning. The maintenance service provider, also known as a support provider, provides support services for an automation solution. It is important to understand that an individual or organization can have multiple roles. For example, a company may have the roles of product supplier and system integrator, or a company may have the roles of asset owner and support provider. Responsibilities can also be, for a role can also be split between organizations. For example, the asset owner may have responsibility for maintenance, but a service provider may be responsible for security monitoring and patch management. The asset owner is ultimately responsible for assigning and documenting the roles and responsibilities. This is a picture of the taxonomy of the term industrial automation and control system used in the 62443 series. The term IACS includes two parts: the automation solution, which is the hardware and software or technical parts of the IACS, and the associated organization security measures to support them. Consider, for example, role-based access control. The automation solution would include the technical security measures to support role-based access control function, for example, a domain controller. The organizational security measures associated with role-based access control would include the processes and procedures, such as identity management, authorization, and periodic account review. The automation solution is partitioned into zones and conduits as part of the risk assessment process described in 62443 Part 3-2. Zones consist of an integrated set of system and security system and component products that have the same set of security requirements. And conduits typically consist of a set of network devices that have the same security requirements. This slide shows the relationship between the principal roles in an IACS. The left-hand side shows the principal role 62443 series. Starting from the top, the asset owner is accountable and responsible for the IACS. The asset owner is also the operator of the IACS. There are two types of service provider. Maintenance service provider is responsible for providing maintenance services such as patch management. Integration service provider is responsible for the integration of system and component products into an automation solution. And finally, the product supplier role is responsible for developing and supporting an IACS system or component product. The right-hand side shows the relationship between products automation solution and IACS. Starting from the bottom, the control system is an integrated set of components such as embedded devices, host devices, network devices, and software applications. The control system and individual components are supplied as products by the product supplier. Next, the automation solution is an integrated set of safety functions, control functions, and other complementary functions. Some of these functions are considered to be essential functions that maintain health, safety, the environment, or availability. The automation solution is designed, deployed, and commissioned by the integration service provider under the direction of the asset owner. And finally, the industrial automation and control system combines the automation solution and the policies and procedures, also called processes, for operation and maintenance. The 62443 standards and technical reports are organized into 4 different tiers. The general tier contains standards and technical reports that are general in nature or apply across all the tiers. The policies and procedures tier addresses the people and process aspects of an effective security program. The system tier covers the technical security measures related to control systems. It is used by product suppliers to create control systems, system integrators to create automation solutions. The component tier covers the technical security measures related to IACS components. It is used by product suppliers to create IACS components such as embedded devices, host devices, network devices, and software applications. It also includes the security development lifecycle for product suppliers. The 62443 series is a collaborative effort among 2 different standards development organizations, the International Society of Automation, or ISA, and the International Electrotechnical Commission, or IEC. This slide shows a complete list of all the available or planned standards and technical reports in the 62443 series. The first column shows the tier that the document is in. The second column shows the reference number for the document. The general format is ISA or IEC 62443-X-X, where XX is the part number shown in the table. In this presentation, I will use the part number instead of the full reference of the document. The third column shows the type of document. There's a technical specification, which is used by IEC. There's a technical report used by both ISA and IEC. And there's international standard, which is also used by ISA and IEC. I should point out that whether the document is an ISA or an IEC document, they both contain exactly the same technical content. The last column shows the publication year of the most recent version. A blank cell indicates that the document has not been published yet, and several of the documents are currently in revision as part of their 5-year update cycle. The standards in bold are considered the key or pillar documents in the 62443 series. There are two life cycles that are defined in the 62443 series: Product Security Lifecycle and the Automation Solutions Security Lifecycle, which has two parts, an integration phase and an operation and maintenance phase. The table shows the security lifecycle scope of each of the 62443 documents. Note that Part 3.3 is the only standard that is used in both security lifecycles. It is used by product supplier to build systems, an integration service provider to build automation solutions, and the asset owner to assess the security of an operating IACS. Product security lifecycle is organized around 8 practices that are described in Part 4-1. The security management practice requires that security-related activities are adequately planned, documented, and executed throughout the product's lifecycle. Practice number 2 is the specification of security. Requires the specification of the security capabilities of the product and its security context. Practice 3, Secure by Design, requires that security has been designed into the product using a defense in-depth strategy. Practice 4, Secure Implementation, requires that product capabilities are implemented securely. Practice 5, Security Verification and Validation Testing, requires that security verification and validation testing include the defense in-depth strategy within the security context. Practice 6, Management of Security-Related Issues, requires the management of security-related issues, including the defense in-depth strategy within the security context. You may also know this as vulnerability management. Practice 7, Security Update Management, requires the timely testing and availability of security updates for the product. And Practice 8, Security Guidelines, requires that user documentation is available that describes how to integrate, configure, and maintain the defense in-depth strategy within the security context. This slide shows the automation solution security lifecycle. The security program must be established and maintained throughout the automation solution security lifecycle. Security specification phase activities are to perform an initial cybersecurity risk assessment, partition the system into security zones and conduits, and specify a target security level. Design phase activities are to perform a detailed cybersecurity risk assessment for each zone and conduit, design technical measures for each zone and conduit, design guidelines for organizational security measures, and the asset owner approves the cybersecurity requirements specification, which is the deliverable from this phase. Implementation phase activities are to implement the technical security measures, implement product security updates, and develop the organizational security measures for operations and maintenance. The verification and validation phase activities are to verify the technical security measures, validate the organizational security measures, and then the asset owner approves the handover of IACS to operations. This is a very important step because this may be the last time to change certain credentials before the IACS is put into operation. Operational phase activities, of course, the asset owner is operating the IACS and the equipment under control, performing organizational security measures for operations, periodically reassessing organizational and technical security measures, and triggering maintenance requests. The maintenance phase activities are to perform the organizational security measures for maintenance, monitor security threats and vulnerabilities, implement management of change procedures, and to periodically update organizational and technical security measures. And then the decommissioning phase activities are the asset owner approves the decommissioning management of change request, purging of sensitive data, and decommissioning of IACS assets. The picture at the bottom shows the relationships between the roles during the security lifecycle. The asset owners are accountable and responsible throughout the security lifecycle. The asset owner can delegate selected responsibilities to service providers, such as the integration service provider during the integration phase and the maintenance service provider during the maintenance and decommissioning phases. And finally, the product supplier provides products, information, and security updates throughout the security lifecycle. There is a certification called ISA Secure that certifies that products are conforming to the 62443 set of standards. During the product security lifecycle, the product supplier submits products and receives certificates that their products conform to specific 62443 standards. There are 3 ISA Secure certification schemes currently available. The Security Development Lifecycle Assurance, SDLA, is based on Part 4-1. The System Security Assurance, SSA, is based on Parts 3-3 and 4-1. And the Component Security Assurance program is based on Parts 4-2 and 4-1. During the Automation Solution Security Lifecycle, the asset owner can require that products used in the automation solution have been certified to SDLA, SSA, and CSA. The integration service provider can select products that have been certified to SDLA, SSA, and CSA. The maintenance service provider can select security updates from product suppliers that have been certified to SDLA. And finally, the product supplier can supply products and security updates that have been certified to SDLA, SSA, and CSA. So finally, additional resources that are available. There is a quick start guide that covers an overview of the ISA IEC series. I'd recommend that you review this because it will cover all of the key concepts and details about each of the individual standards that are in the 62443 series. There is a quick start guide on ISA Secure certification. There's a white paper on security life cycles on which this presentation is based, which has been published. There is a link where ISA IEC 62443 standards and technical reports can be purchased. The ISA certification scheme can be found at isasecure.org. And there is ISA training on cybersecurity and the use of 62443 that's available also at isa.org. And finally, there's a book that is available from ISA on performing security process hazard analysis reviews. Okay. With that, Matt, do we have any questions?
Yes, we do. And thank you so much for that great presentation. We are going to move into the Q&A session now. But before we do that, I'd just like to mention that the slides are available as a download on your screen. If you click on the Resources tab on the bottom of the screen, you should have access to a PDF copy of the slides, including the Resources slide with all of those great links and information. All right, now for our first question. Okay, let's see what we have. Can the CSMS from the asset owner be certified?
So currently, there is not a certification that's available for the security program based on 62443 or an automation solution itself. Generally, it's difficult to do a certification of that. It is more appropriate, perhaps, to do an assessment of that. And there's another aspect that should be mentioned is that the enterprise will have an information systems security management system, and the cybersecurity management system for the industrial control system should be coordinated with that ISMS. But so the answer is to this specific question, as far as I know, is not at this time.
Excellent. Thank you for that. Okay, now our next question from the audience. This seems very familiar to the IEC 61511 lifecycle format. Can you contrast the two standards?
So that's by design, actually. The 61511 standard and the life cycle in there was used as one of the source documents to develop Part 4-1, which is the life cycle. Part 4-1 and 3-2, which are used as the life cycles. And there is also a working group in ISA 84 that is working on a document that that integrates the life cycles that are presented in 61511 and in 62443. So there will be a technical report that comes out pretty soon covering that topic.
Excellent. Thank you for that. Okay, moving along to our next question. Protection level is a term now seen in IEC 62443 framework, apparently defining how security and maturity level will generate a combined protection level. Can you elaborate protection level? Further, when is it expected that IEC 62443-2-5 will be public?
So this topic of protection level is actually in a document called 62443-2-2. And the protection level is an intention to combine the technical security measures and the organizational security measures into one entity that can be used for the assessment of an automation solution that is in operation. And so, yes, it combines the security, the technical security, using a concept in 62443 called security levels, and it combines the organizational security measures in 62443 using maturity level, to combine that into a single topic called the protection level. And so hopefully that's enough elaboration.
Excellent, great, thank you. Okay, another question from the audience. Can you define the terms conduit and zone in a bit more detail?
Okay. Yeah, perhaps the next time I do this, I should add a slide on conduit and zone. So a zone is defined as a list of assets that have common security requirements. And then conduits are the connections for data communication between those zones. And so you can think of the zones in a couple of different ways. You can think of a physical zone, so that's a set of assets that are in a control center or in a control room. You can also think of zones as in terms of network segmentation. So there's different networks, different subnetworks that are connected together with conduits. The basic concept is that you want to protect and restrict the data flows between those zones using conduits and firewalls, things like that.
Excellent. Thank you for the explanation. Okay, let's see what's next. Okay, next question from the audience. Is there any training institute that provides cybersecurity training, not certification, covering the aspects of computer networking, network security, ethical hacking, etc., keeping in mind the skills and techniques required for the OT cybersecurity engineer / consultant / system architect, etc.?
Yeah, so there are a number of training courses that are available for the general IT security, which is the things that are mentioned there. There is a set of courses that are available from ISA that are specific to the security for industrial automation and control systems, or some people call that operations technology. And is also specific to implementing the 62443 set of standards. So if you go to isa.org, there will be a set of courses there that are specific to industrial automation and control systems and 62443.
Excellent. Okay, next question from the audience. Looks like a bit of a follow-up here. Can you contrast 62443 projection level with 61511 integrity levels? Is there a similarity and or difference?
Yeah, so they are definitely different. The integrity levels are specific to safety integrity, and the protection levels are specific to overall protection provided by a security program and the technical parts that are a part of that security program. And so no, they are not the same thing. Safety integrity levels are also different from the security levels that are defined in 62443. So those are also two different concepts. But the heritage of the security level did come from the original safety integrity levels. The idea of organizing requirements in terms of security levels, was inspired by the safety integrity levels. But they are very different things.
Excellent, thank you. Okay, another question from the audience. Is it possible to do any of the certifications provided by ISA for personnel, or do you have to get certified in first level and then level up?
I'm not really sure about that. Perhaps we can take that as a follow-up, Sandy. Perhaps you can.
Not a problem.
We'll have all the. And I'm taking this. These are the certifications for ISA, like cybersecurity design. There's several of them related to 62443. So we'll follow up with that question.
Excellent, thanks. Yes, and we have all the information, so we can follow up after the webinar. Okay, moving along. We have a few more questions in the queue, so we'll try to get to them before the end of the session here. Okay, our next question. Does the ISA/IEC 62443 series of standards cover industries outside of process manufacturing? And what other industry segments are using the standards?
So there is an activity underway in the IEC to designate the 62443 series of standards as what they call a horizontal standard. It's not quite complete yet, but that work is underway. When 62443 becomes a horizontal standard, then it will be applicable to a number of different domains, you know, transportation, nuclear, buildings. There's a number of different domains that would be included in that. And so they do cover industries outside of process manufacturing. You know, I know of several industries that have looked at 62443 as a guidance to develop their cybersecurity standards for industrial control systems.
Excellent. Thank you for that. Okay, and we have a follow-up from the certification question. Can you recommend some book or guideline that provides information on the implementation of 62443?
I'd recommend looking at isa.org. They have several books that are available on the basic concepts behind security for industrial control systems. I did mention one that was specific on my resources page, which is on the risk assessment process, cyber PHA risk assessment process, which is a very important part of the overall life cycle and management of risk for industrial automation and control systems.
Excellent. Thank you for that. Okay, we have a few more questions. Okay, our next question. How does the committee handle updates to the series? How and when are those updates made?
So you'll notice that each one of the standards has a year, a date associated with it. And when a standard is released, there's a 5-year cycle that starts, and there's an expectation that every 5 years the standard is reviewed and, if necessary, updated. And so, as I mentioned before, several of the ISA IEC 62443 documents have been released before 5 years, so there's several of those that are currently in revision.
Excellent, thank you. We have 2 more questions. Okay, next question. Who should lead the conversation about the roles and responsibilities for a particular project, and when should that conversation happen? Should this guide be referenced?
So the asset owner is responsible for having that discussion. The asset owner, it's important that they have that discussion very early in the project. So it's one of the first things that needs to be done. They're responsible, the asset owner is ultimately accountable and responsible for the IACS, but they can delegate certain responsibilities to integration service provider, maintenance service provider, a security service provider, if that's the choice. But it's the asset owner that's responsible for that. And it has to happen very early in the life cycle of the industrial automation and control system.
Excellent, thank you.
Should the guide be referenced? The answer is yes, but it's really the standards that are the key documents that need to be referred to.
Got it, thank you. Okay, it looks like, we have 2 more here. So next question. Will ISA GCA update this guide as the series of standards are updated, and where can I find additional resources from ISA GCA?
So the answer is yes. As the standards change, the we do have a plan to update the two guides, the three guides that we have. I don't recall offhand the URL for ISA GCA, but I'm sure if you do a search, an internet search for ISA space GCA, that you'll be able to find that.
Excellent, thank you for that. And looks like we have one last question, so here it is. Is the role of cybersecurity for IACS manager recommended or required?
So as far as I'm aware, it's not a requirement to have that role in the ISA IEC 62443 standards, but I would recommend that there is a single person that is responsible for coordinating the activities, probably in a large organization at multiple levels. You know, you'll want to have a manager that's responsible at each local facility, and also someone that's you know, higher up in the organization that is able to set policy and procedure and the standards that will be used. So it's not a requirement, but I would recommend that. And in fact,
Excellent,
I held
thank you.
that role.
Oh.
I held that role in my previous with my previous employer.
Nice one. All right, well, that was our last question, so it looks like we're going to wrap things up right there. Johan, thank you again for taking the time to be with us today and also taking the time to answer some questions from the audience.
Okay.
I'd like to also thank our audience members for being part of this webinar event. You will be receiving an email from us with a link to the on-demand version of this presentation, so you will be able to come back and watch this again or share it with your colleagues. Lastly, please take a moment to complete a survey which will appear on your screen at the end of this live webinar. For on-demand viewers, you will find the survey located along the bottom of your attendee console in the survey widget. Again, thank you for taking the time to attend this webinar event. Take care, and we will talk with you soon.